Now, in order to find the derivative of square root of x, we're going to use the power rule on this function here, square root of x. But before we use the power rule to find the derivative of the square root of x, we need to first figure it out, and we first have to recap on how to use the power rule itself. So let's use an example problem here. Let's try to find the derivative of 2x squared, and using the power rule. So to use the power rule, you will first need to multiply these two numbers. Multiply the exponent with the constant, which gives us 4x. With the power rule, it also asks us to subtract 1 from the exponent, which then gives us x to the power of 1, which simply just gives us 4x. And simple as that, that is our derivative. Derivative of 2x squared is 4x by using the power rule. Now, I dropped my pen there. To use the power rule when it comes to square roots, we first have to set up this function to be eligible to be used the power rule, which gives us our first rule when it comes to square roots. Square root equals 1/2. That's rule number 1 when it comes to using the power rule when it comes to square roots. Because of this little rule over here, that 1/2 would then become the exponent. So let me try to do this. There we go. So with that knowledge, x becomes x to the power of 1/2. And simple as that, we can this function now becomes eligible to be used the power rule. So like that, we use the imaginary one here by the x, multiply the exponents, which becomes 1/2 x, subtract 1 here, which gives us negative 1/2. And just like that, we have the derivative of the square root of x. 1/2 x to the power of negative 1/2. Now, of course, there's more than this. So let's go for the next one. Let's go for what happens if there's a function. Let's go for the example, square root of x, and this x is being powered by a number. So by power rule, to use the power rule, we first have to set it up into a function. But as well, we can't really use the first rule because the x is already being occupied by an exponent. So that gives us to rule number 2 when it comes to square root functions of using the power rule. If the x is being powered by a number, that x then becomes in parentheses and is still being powered by 1/2. But with that, these two numbers will then be multiplied. It will multiply the exponent. So knowing that, x to the power of 5 will be in parentheses, being powered by 1/2. We will then multiply the exponents, which will gives us x. Oh, that's not a good color, is it? Let's fix that right there. It gives us x 5/2. And now there will now be eligible to be using the power rule. So let's use the imaginary number that's provided by the x to give us 5/2 x, and the power rule says if we subtract here, which gives us 3/2. So there we go. And then we have one more step to go to use the power rule when it comes to square root functions. An example here, I try to work on it as the best I can. But let's go for a bigger number. Let's go for a big number here. We got 8. Oh, don't have the paintbrush. We have 8 the square root of x to the x cubed. But in this function, there's a 4 in the square root. Now that gives us the third rule when it comes to this. And the third word being that if there's a number in the square root, that number now becomes the denominator. So that's our third root here. So with that knowledge, right, we'll leave 8 by itself since it's a constant number, in parentheses x to the third, since it is by signature of the second rule, and then it's being powered by 1/4. Now using the second rule here, we then multiply these two, which gives us 8x to 3/4. Oh, that is not a 3, that's an 8. 3/4. So now with that, we'll be asking, well, what do we do with the a? Well, it's simple as that. We will multiply the exponent with the constant here. So this and this we multiply. So simple as that. We have 24 over 4, which be simplifies to 6. So we have 6x. And then we'll subtract here, which gives us negative 1/4. And just like that, there it is. The derivative of 8 to the square root of x to the power of 3, with a number in the square root. So just to recap, I'm pretty sure I'm a little over my time here. In rule 1, square root is equal to 1/2, which becomes the exponent if there's no number in the square root and if x is not being powered by any number. As well, in the second rule, in the green, if x is being powered by a number, you will put the x to the power of the number in parentheses. It's still being powered by 1/2 because that's how the square root is. But both exponents will be multiply each other, and then by then you will use the power. And then finally, on the red, final rule, if the square root has a number in the, if the square root has a number, that number will now become the denominator. This is how you use the power rule when it comes to functions that have a square root. The main goal is to get rid of the square root to then be eligible to use the power rule.